In this lesson, we are going to discuss how you can load data files into Python environment. In our previous lessons, we discussed how you can use Python as a programming language to solve your scientific and business domain problems. How you can code using a code editor or IDE integrated development environment such as Visual Studio Code or Jupyter Notebook environment. I assume by now you have a good understanding about Python syntax. In this lesson, we will be exploring different data file types and how you can load them into Python and then how you can use them in a typical data analysis routine. My name is Sumudhu Tenakon. I'm a data scientist. I'll be helping you through this course to navigate your data science and AI career. Lesson outline. This lesson starts with discussing different data sources and file formats you should be expecting in any typical data analysis workflow. Then we will move into Python notebook environment and we will explore how you can handle different data file types, how you can load them into Python environment. We will explore text files, Csv files, Json files, and Excel files. After loading the file, we will explore how we can access the data in those files after loading to Python environment. I assume all of you are familiar with Excel. I assume you used Excel to do at least simple data analysis tasks such as loading a file, creating columns, doing some calculations, creating summaries, and plotting in Excel. During this discussion, I will connect your understanding about Excel with the Python. The same thing you can do with Excel, how you can do the same thing in Python. That will help you to understand the Python side better with your current understanding of processing tabular data with Excel. If you don't have Excel understanding or knowledge about Excel, how you can do data analysis with Excel, don't worry, you can catch up during this lesson. Before discussing about the data sources and data files, let's try to review our understanding about the data. We use data as attributes to describe things in nature or the things in business domain such as person, a vehicle, or a building, or a document. So everything you can model as an object in data world. So those objects can have attributes. So we use different forms of data to store those attributes. If you talk about a person, so a person can have attributes such as date of birth, name, age, or hair color, gender, height, weight. You can name many. You have many of them in this slide as well. So those characteristics or attributes we have to store in some form for future use or to do some data analysis work. Let's explore the tabular data. So when data describing a person, we understood in our previous slide, the attributes can describe a person. We can put that data into a table. In this table, columns represent each attribute from multiple people and rows represent individual person. For example, a table you have rows and columns. Row 1 will represent a person 1 named John Doe, and we can record the ID of that person, name, and date of birth. Row 2 is the row belongs to Jane Doe, and the first column, ID column, will have the ID, and the second column will contain the name, and third column will contain the date of birth. In a semi-structured data, we are using some kind of hierarchical format. If we still keep the example of people data, so the same table we can convert to a JSON object. So that object can contain a JSON object named people. So that people JSON object is not just a JSON object, it's an array of JSON objects, can contain data about multiple people. In this case, each JSON object will represent a row in the previous slide or in a table. In a JSON object, we have things like one is key and the other one is value. So key is things like name, age, date of birth will become key for the innermost JSON object, and the Jane Doe is the value for key name. 32 is the value for age. For the innermost JSON object will become a value for the outermost JSON object named people. Like that, you can maintain a hierarchical format with JSON. If we talk about XML, which we are not going to discuss in this lesson, we can also put a hierarchical format on the markdown tagging. So you have the people tag, and then under that you can have multiple tags of like person, and then under that you will have attributes, name, age, date of birth as different tags. You can work with XML with Python as well, and also you can load XML files to other platforms. When we are working with data, we can find data organized into many different forms. In structured data, such as tables and relational databases, you have a nice organization of data. You can find in a table, you can find rows and columns. Columns represent attributes, rows represent individual records or observations. In unstructured data, you don't have a clear structure, as the word suggests you, such as random emails, social media posts, text messages, videos, photos, and customer reviews on a product. In a semi-structured form, you can have a mix between structured and unstructured. So the JSON files, XML files, and then files labeled and organized into a folder structure, emails organized into mailboxes, can be considered as semi-structured data if they have like some form of organization internally. So in the data world, most of the data available these days are unstructured or semi-structured. Those generated from social media, those generated from streaming channels. So most of the data are kind of unstructured or semi-structured. Some of the business domain data exist as structured data. One job of a data professional could be take the unstructured data and convert them to structured or semi-structured data. In this lesson, we are not going to talk about unstructured data. We will be mainly focusing on structured data such as tables and semi-structured data such as JSON files. Let's talk about different data sources you will be getting in your data work. We can have data in files or tables like we already discussed in the previous slide. And also we can have as tape drives or films or data stored in a database as tables, or maybe as a sound recording, could be images, could be paper documents such as book chapters, or data could be simply downloaded from the cloud. So data sources can vary within a project. So for a one given data analysis project, you should expect one or more data sources and one or more different data file formats. In this lesson, we are going to explore mainly about file data and the tabular data. Here are some data file types we're going to work with in this lesson. Text files can come with extension .txt or .dat. Sometimes it comes with variety of extension. Because text files are something you can easily open from a notepad or similar application, and you can view what is inside. CSV files or comes with .csv extension are also text files, but there's a specialty. Each row in a text in this text file is considered as a row in a table. Each column will be separated by comma. So in a row, you will have comma separated values. If you have a comma between two values, that means those two values belongs to two different columns in a tabular data set. So that's why comma separated value in short form we are giving to CSV files. We are working with JSON files, comes with the extension .json. So like you saw in the previous slide, JSON files can come with a hierarchical structure with key value pairs. We also work with Excel files in this lesson. You all know what is Excel file. You can open Excel files using Excel or any spreadsheet applications. Next, let's try to explore the Python notebook to learn how we can deal with different data files, as you've seen in this slide, as well as text files, CSV files, JSON and XLX files. Are you ready? Okay, so let's start with our notebook discussion. Before we begin, I would like you to have an understanding of what are the libraries we will be using. By now, you should have a better understanding of how to use Python in general, NumPy library, Pandas, and Matplotlib. We will explore them during this section as well, but make sure you review what you learned from the previous lessons before we begin this lesson. This is the notebook number 1 of series of notebooks. Will guide you through the example workflow of loading, analyzing, and visualizing tabular data using Python. We will be mainly using Pandas library in this work to load and manipulate data and to store data. We will be using Matplotlib for the data visualization. We will be using some other Python libraries also to some nice data visualization outputs. Let's try to explore what are the files available to us in this lesson. We have 4 files. First file is a simple text file. We call it sample file.txt. Other 3 files have the same data. They contain the same data, but they are in 3 different file formats. The first file is a CSV file or comma separated value files. Second file is a JSON file. Third file is an Excel file. So the first file, sample file.txt, you can open in simple Notepad, such as Notepad or Notepad++. This file contains 2 lines. First line said this is a sample text file. Second line say welcome to Python programming. If you open the second file, zooanimals.csv, it will display like this. CSV stands for comma separated value. As I mentioned earlier, you can see clearly here each value is separated by comma in the same line. So that indicates the column ID and animal. They are column headers, animal name. So they are 2 different columns. They belong to 2 different columns. The first row in this file contain column names. From second row onward, they contain values. You can observe the values and they are separated by commas. So that will tell you the first column ID. So from the second row, the first value before the comma is belong to the ID column, and the second column is animal name. Then after comma, you have the second value belongs to second column, like that. That pattern continues. How we can identify the line break to define the row limiter? We know the column limiter is the comma. How we can identify the column? So the column delimiter or column limiter is new line character, or how we can define in this file is a carriage return plus feed forward. So we can enable some feature in this Notepad++ to see that character. You have to go to show symbols if you are using Notepad++ and say show all characters. You will say carriage return plus line feed. That is like a new line character if you load this to Python. So you will see this character is the row delimiter. Okay, so now you know in a comma separated value file, comma is what you are using to define column delimiter, and carriage return plus line feed, which is a new line character, is what you are using as a delimiter for lines. So that's how you understand the line boundary. All right. So the other file is a JSON file. JSON file you can open in Notepad. If you open it, you will see like a bunch of characters with some strings and numbers. So it's kind of a messy here, but I will take one value out of it. So one row out of this this JSON object. So if you do that, you will get something like this. So I made it like making it like nicely formatted. So this represents one row. So let's try to switch off our show all characters option. You will see key value pairs clearly as you saw in the slides earlier. ID is the key and 1 is the value. Same as that, animal name is the key, antelope is the value for animal name. In a JSON file, if you load into Python as a table, or if you convert a table into JSON file, your key will become your column name and value will become your cell value in a tabular data set. Now you know we can convert JSON file into a table, as well as table you can convert into JSON format. When you convert table into JSON format, there are many different methods of doing that. So this method we call records. So each JSON object consider as a record or a row in your data file or data table. So if you have multiple rows in your table, they will become an array of JSON objects. So that's what you see in this file as an array of JSON objects. Start with the square bracket that defines the array in JSON. And then you have like first JSON object, that's the first row, and the second JSON object, that's your second row, and go on. So you have like number of rows in this file, each belongs to one JSON object, and they are inside this JSON array. So now you know how you can see a JSON file in a text form, in a text editor. So now let's see how we can visualize in a browser. So browsers such as Firefox, you can open the JSON files in browser. If you open in a JSON file in a browser, it will render the JSON file into another format. You can play with it, so you can find the hierarchical structure. You have the first row, second row. You will get a nice visual out of it. So I will make it zoom in a little bit to show you more clear. So you see the first row, it's nicely rendered, and you can even select values, and you can collapse first row, and you can see the second row. You can collapse it, you can collapse all, right? Or you can expand all in Firefox, or you can filter out. So you can, if you wanted to do something like antelope, so you want to search something, you can even do that. So the JSON viewer in this Firefox browser will be a powerful tool in that case, if you wanted to do a quick data browsing in a JSON file. All right, so now you know another way how you can read a JSON file before you go into a Python environment. This is an Excel file containing the same data. It's a regular Excel file. So if you can open this Excel file in Excel, so I'm going to open it right now. So there you have, I assume you all have some familiarity with Excel, and you worked at least very simple data analysis tasks in Excel. With that assumption, I will introduce to you like few things, and I will try to go through this very quickly, because what we are discussing here is very relevant to our discussion on Python, how you can handle the data set in Python. Okay, so in an Excel file, we call this page as an Excel sheet. In an Excel file, you can have multiple Excel sheets. You can recall your lessons you previously gained from somewhere about Excel. Or if not, you can read more about Excel or watch some other videos or tutorials about Excel. All right, in an Excel worksheet, we have rows and columns. Rows in an Excel sheet will be defined by the row number starting from 1. So this is your first row, this is your second row. Columns defined by alphabet characters A, B, C, D, and up until C, and then after that you have AA, AB, AC. It will continue. So you can find you can have like several millions of records in an Excel file. You can have another large number of, I don't remember the exact number of rows and columns you can store, but I know like at least 1 million rows you can keep, and then maybe several tens of thousand columns you can keep. That's a big file with large number of cells in one Excel sheet you can hold. Okay, so like I said, each column will define by a letter, and the row will define by a number. Right, so row and column will give an address. for that cell. For example, in this cell, I'm putting my cursor into is called B2 because it's coming from column B and row 2, right? If I click this cell, so this is row 10 in column G, that's why it says G10. So this is where you can find the cell address. Okay, so any cell you can click and edit, you can put any value to it. So there are other things I don't want to go into very detail. You can set a data type to each cell or each column. You can select the data type, right? So you can select whether it's a number, whether it's a floating point number, whether it's a currency code thing you wanted to format the cell. So many things you can do with Excel. So Excel is a very powerful tool, and not only the Microsoft Excel, there are other Excel like applications, spreadsheet applications available. You can use. All right, so I think that is enough about the Excel. We will come back to this later when we are discussing about the data analysis, because I wanted to compare the things you can do with Excel and how you can do the same thing with Python. You can ask like why we are doing, if we can do this everything with Excel, why we are going to Python, but I will show you what is the importance of learning Python, how to do this data manipulation in Python than Excel in some situations. Okay. All right, so this file you can also open this file. You get this file under resources. You can download this file and open in your Excel viewer or Microsoft Excel or any spreadsheet application you're using capable of opening XLS file. You can open and see what is inside the file, right? So let's go back to our notebook. Our first task is to load data from files. Before we do anything with Pandas, so I want you to explore how we can deal with base Python functions available to load a text file, and then with the base Python libraries, how we can load a CSV file and Json file before we going to Pandas directly. This could be useful in some situations, therefore I would like you to get familiar with them. Okay, so let's see how we can load a text file. So you previously explored our text file called samplefile.txt, which is this file. So let me open this file. So this is your samplefile.txt. Our goal is to read this file and load content of these two lines into Python. So let's see how we can do that. In Python, there's a built-in function named open. What it does is it will create a file pointer. If you're familiar with other programming languages, you can think this is as a file pointer, but this is an object which holds the file reference. Okay, so this opened the file for you. You have to provide file path. You have to provide whether you're reading this file as a read-only file or read-write file. You have to provide that option, right? So even if you don't provide it, it will take as a read file. When you are providing path, we discussed this thing earlier as well when we are discussing about strings. You can provide the path as a row string, because when you're providing a Windows path, your slash character will consider as an escape character in some situation, which will misidentify that as a escape sequence, and then it will read as a different character than a character you expect in your file path. Therefore, it's always safe to use R string or row string. Okay, so like I mentioned, this FP is an object which holds the file reference, but it will not contain file data yet, even if you say open. So it's just opening the file and ready for your use. If you want to read lines in this file, in a text file, we can say the data is stored in lines, right? You can have like one big line contain everything, or you can have multiple lines containing your data. It could be a paragraph. It doesn't need to be a table. It could be paragraph or number of paragraphs, like an essay or like an entire book. Anything it can contain in these text files. But if you want to read lines, if you wanted to read the file content, and then if you wanted to take the lines as an array or a list, so you can say fp.readLines. This is the function from this fp object. what this does is it will read the content in that file and create a list of strings. Each item in that string list will contain a string of rows in that file, right? So this is your first row. We all saw the file earlier, and this is your second row. All right, if you wanted to check the file again, so this is the file. You have the first row and you have the second row. You saw your file is read properly, and we read like the 2 lines in that file and created a list of lines. Okay, another observation I wanted to point out here, you see the new line character. We saw that that character is courage return and line feed character in the file, as we saw in Notepad++. So that will read as the new line character in Python. So that will be the way you can read the text file. All right, so now we can load the file again. One other note here is, once you do this operation, once you read everything in this file object, you will no longer can read it again, because that reference will get to the end of the file. So if you start reading again, you will get an empty string. So let's try to explore that. Because you came to end of the file, like I mentioned earlier, this does not contain any data about the file, but a kind of a reference. So it will move the file cursor to end of file, and if you call read lines again, you have nothing to read from the end of the file. If you want to call read lines again, you have to recreate the file object. Or you have way you can go back to your file pointer, you can take it back to the initial position and read it. I'm not going to discuss in detail about these file operations, because I'm going to deliver it in another additional resource. You can find under resource, because that is not very directly relevant to our data analysis lessons we are having here. But if anyone wanted to know about how to read and write files with more details, I will put it under resources as a different lesson. Okay, so then let's look at how we can read a single line at a time. Like I said, the file reference will keep a pointer to a location starting from the very beginning of the file. If you call this read lines, remember the earlier we called read lines, read everything as lines. Here what we are doing is reading one line at a time. In the first call of this function, it will read the first line. It printed the first line as we expect. When you call it again, fp.readLine, it reads the second line. If you call it again, in this example, you will get an empty string, because you are at the end of the file. You read first 2 lines, and those are the only lines available in this file. Okay, so now we can call another function. The function called read. Difference between read line and read. Read lines will read all the lines line by line and convert into a list of lines. Read will also do the reading entire file, and it will convert everything in that file into a string. So let's see how it works. Again, like you have to recreate the file pointer object if you want to do it. So then you can because if you do it without doing that, so you have nothing to read. Your cursor is at the end of the file. So let's do that. You see this read everything as a string. Now there's no 2 items in as a list, so it will be one string. You have the first line and then new line character to denote the line delimiter, and then you have the next line, and then you have the line delimiter again. Okay, so now you know a third function. If you want to read the entire content of the file, so you can call read. Okay, so the next one you can use in the file is or you can read all at once. We can print everything. So before we are printing, we are doing like something more. So we are assigning whatever is returning from fp.read. So here we just displayed in this notebook, we wanted to keep it in a variable. We are assigning into a variable called file data. So this contains entire thing in that file as a string. Okay, so we load it to string, and then we are going to print it. So this is how if you print. The reason you did not print as 2 lines, because we are just seeing what is inside this fp read return object or there's a string, you have the new line character. But if you explicitly call print function in Notepad or in Notebook or in Python command line, you will print without printing the new line character. Instead of that, you will see a line break. You see the first line printed as it appear on the text file, and then line break, and then the second line. Okay, so another important thing you have to remember is every time when you open a file in Python, you have to make sure you close the file. Otherwise, there will be some errors and file locks can created. Another process cannot access your file you open in Python. There are many inconvenient situations can happen. Therefore, it's a good idea, or I think you must close the file once you're done with working in that file. Okay. Another, if you wanted to avoid such situation, if you don't want to close the file, sometimes if you use this way, you are opening file, working with the file, and then closing the file. If in any case you missed this line, so there you will face into some trouble. To avoid such scenario, Python have like a clever method to avoid such scenario. You can use with. So with will help you to run file handling commands under control of context manager. So you are invoking a context manager. What it does is it will take care of opening, closing, and any errors within that operation. So if you call with open, right, and then you can assign your file pointer into a variable, same as you did above, but here you are saying with open this file as file this fp as a Python object, and then that fp will be same as the object fp you created above, and then you can work with that file object and do whatever you want to do with it within this with, right? And then in this example, I'm reading the file, assigning it to a variable and printing, and then after executing this, file will be automatically closed. You will not have any errors or any situation where you had it without using the with. So let's execute. So it will do the same thing as above cell, but you don't need to explicitly close the file. Okay, so that's about text files. So now let's look at CSV files, how we can process CSV files without using Pandas, using base Python library. So the CSV is a Python library, comes with Python. If you install from python.org, you don't need to install CSV as a separate package. It comes with the base Python distribution. All right. So to do that, the operations will be a little complex. Again, I'm not going to very detail about how the CSV file reading, but I will give you like in very high level to get an idea of how the process works in a CSV file. We all know from our observation, CSV file, you have commas to separate columns or cell values, and then new line character to separate individual lines. Right? So that's how a computer or Python or any reader understand a CSV file. Okay. If you use a CSV library, first you need to create the file object, same as we did above as a text file. Remember, CSV files also text files. You can read in any text editor, and also they are containing same text content. So you can open as a text file in read mode, and then you can create another object called CSV reader, so which is coming from the CSV library csv.reader, and you have to provide the file pointer or the file object in Python, and then if you provide that, it will create a CSV reader pointing to that file, CSV file. You can use that CSV reader later if you wanted to read something out of that file. So how we read in this Python program? So you have to run a loop to do that. So we learned about loops in our previous lesson, right? So here I'm going to use a for loop. I'm creating a for loop to iterate through rows in this CSV file. So that in CSV reader, you will if you say in CSV reader, if you iterate through this CSV reader, it will get row at a time. So what you are doing is you are appending this row into the rows we created an empty list of rows. So it will create an empty string in this line, empty list in this line. And then whenever you are iterating through each row in the CSV file, you are appending those rows into the rows list. Ultimately, or at the end of the execution, you will get a list of rows containing comma separated values in the CSV file will decode into another list. So basically you will get list of lists. So let's see what is the result of this execution. You see, like the first row we know contain column names. This came as your first list item, which is another list. So this is a list of lists. Remember, we discussed about this, creating lists of lists, list of tuples, list of dictionaries, right? We can do many list things out of list function in list in Python. So this is a list of lists. So first item of this list contain first row, second item contains second row. Here I am using the limiter in Python. So you can say this will say it will load like 100 rows. I'm going to display only first 2 rows. So this instructs Python to Python list to show everything from beginning up until the row index number 2, which exclude the row 2, right? So it will display row index number 0, which is the first row index number 1, which is the second row. Okay, so that's about the CSV file. You can try this out in your own. You can load the file. You can also get the CSV file in the under resource section. You can load it and you can try it out. You can print more lines if you want when you are trying. Then let's look at how we can deal with JSON files in base Python library. So that library called JSON. It also comes with Python distribution. You don't need to install separately. The JSON file, we know that this is our JSON file in that drive. We saw the JSON file and we are open in Notepad document. So if you open this JSON file as a text file, JSON file is also a text file, very similar to what you did with the CSV. You can create a JSON dictionary out of JSON object. So when you are reading a JSON string or JSON file containing a JSON as a string, you can call json.load. Okay, so when you are calling a file, you are loading from a file, we call json.load and then file object. So if the file is a JSON file, it will load your JSON object and convert your JSON object into a Python dictionary. Python has no native version of keeping JSON data. Therefore, it will the native more closely related data structure in Python is dictionary. Remember our discussion on dictionaries. So we have key value pairs in dictionary, which is very similar to JSON data objects. So we can store them as a Python dictionary. So this load function will do loading a file content into a JSON file content into a Python dictionary. If you have JSON, we are not going to discuss here, but for your additional understanding, if you have a string, you hard-coded a string or you read a string from somewhere, if you wanted to that string contain JSON object, if you wanted to convert it, so you have to call json.loads, s at the end of the function. So that stands for string and not for loads as the verb. So it's s stands for string, so LOADS, and then you have to provide a string value within parentheses. It will load your string version of your JSON object into a Python dictionary. So that's how you can convert JSON to dictionary in Python. And in this case, we are converting or we are loading a file containing JSON object into Python. Okay. So now you know how we can deal with text files, CSV, and JSON. So let's explore how we can deal with Excel files without using Pandas. Python has a library called OpenPyExcel. So this library is not coming with the base Python. Therefore, you have to install if it is not installed in your environment. But if you are using a Google Colab or any other standard Python distribution, like such as Anaconda Python distribution, OpenPyExcel is included. You don't need to install, but if you, in any case, you don't have it, you can install using pip install. Go and review our lesson on how to install Python libraries. You can install OpenPyXL in that method, either pip or using conda. Okay, so in the OpenPyXL, we have a function named like a load workbook that will create a workbook object. So we first need to import the library, the function, or from this library, and then that you have to provide what is your Excel file location. You have to provide the file path. So when you provide your file path, it will create a workbook object. So I name it as WB, so stand for like workbook, and this workbook object contains sheets of the Excel file and all the content of the Excel file. So that is going to refer into that Excel file. Again, it's not going to load data still, but it will refer into Excel file. You can use this object to access the content of your Excel file, same as the file reference or file object we created above. Here, another thing I want to do, I wanted to get my Excel files first sheet, right? So if you call wb.worksheets, it will return a list of worksheets, right? So this expression will return list of worksheets. If I want to get only the first worksheet, this is how you can do that. Since it is returning a list, you can pass 0 index as 0 as the index, so it will get you the first item in that list. So that I'm going to assign into another object or another variable named sheet, because here I know I open this Excel file, I know there's only one sheet and I just wanted to load that sheet. If you don't know what sheet exists in this Excel file, you probably need to run more commands to know what are the sheets available, what are the sheet names, and how many sheets available. You need to probe the workbook, or you need to query using some other commands in this workbook object. I'm not going to go into details. I will also add another resource for you to learn more about the workbook, how you can deal with this OpenPyXL workbook object and do some tasks. So that learning could be important for you for some automation task with Excel files, but not related to our data analysis work, because our main focus to learn how to use Pandas to do this data analysis work. But here I just wanted to introduce to you some other ways of doing if you don't have Pandas, or if you don't want to use Pandas for any reason. All right, so here let's try to run this command and explore. It will read your notebook file, and then it will again, like same as the CSV file, it will read get the first sheet, and then same as the CSV file, what we did with CSV file, we create a row empty list, and then we are going to iterate through each and every row, right? So the sheet dot iter rows, iter underscore rows, will iterate through rows in your workbook worksheet, or the sheet. And then we have an inner for loop in this case, because each row will contain cells as another object. We wanted to read inside cells, right? So the architecture of the workbook, I'm not going to go into very detail in this lesson, but in my other resource you can find it out. What we need to do is we need to read each and every value of this cell. So the inner for loop will take care of that. It will extract cell values and then create your row as another list. That's the row values is the inner list, and then the resulting row value list will be appended to the rows list, same as we did with the CSV. The additional part of than the CSV, you have this one. Okay, so after we do that, here also I'm going to print only first two rows. So you get the same output as we get from the CSV file. You can explore this, you can play with it. If you wanted to learn more about it, you can read the OpenPyXL documentation or follow some examples. There are plenty of examples available, some tutorials also available. If you don't find any, I can guide you through from my other external resource. All right. So let's go to our main part of the lesson, which is how we can use Pandas to load data files. First of all, we need to load Pandas library. So we are now familiar with loading a library. So we are loading Pandas library, import Pandas, and then we're creating an alias called PD. So that is a kind of a standard alias. Everybody create Pandas as PD, numpy as np, like that, right? So we can load pandas as pd. Later, when we are referring to any function or object or submodule, so we call pd dot in our code. All right. You saw previously how we can load a CSV file. It was not that convenient, right? So you have to write a for loop. You need to take care of some, appending rows and creating a variable. The code line, like several lines you have to code. Right? But if you use pandas, so see how easy it is, because they are taking care of everything you wanted to do in Python when you are loading a CSV file into Python. So you can simply say pd dot read CSV. That's the function in pandas, and then provide the path. There are other parameters I'm not going to discuss in detail here. You can read the pandas read CSV documentation from pandas documentation. I have the link above in this notebook. You will find out the more parameters. While we are working on some examples in our next few lessons, I will introduce them one by one. For example, there's a parameter to say if your file contain your column delimiter is not comma. So there are file formats like that. In some file formats, you should expect column delimiter as the tab. In some file formats, you can expect a column delimiter as a semicolon, or maybe as a pipe character. Right? So then you have to provide what is your column delimiter to this function. There's a parameter, you can set that. There are other things also we're not going to discuss in detail. Okay, so if you execute this command, it was not executed the import part yet. So okay, so now I imported the pandas, and then if I execute the command read CSV, or the Python statement read CSV, it will read the file and then assign to csv._df, which is our data frame object. So this will read your CSV file as a data frame, and then assign to the data frame object. We are creating a variable to hold the data frame object. And then the next thing we will be doing here is instructing Python or to using the pandas function name head. So what this does is it will print first 5 rows to screen. It will actually not print, actually it is returning first 5 rows of that data frame. And then if you are doing this in a notebook, it will print immediately. If you are doing this in a .py file as a script, you probably can assign it to another variable if you wanted to keep it, or you have to put it under print statement like this. You have to say explicitly print this. So if you do this, it will print your first 5 rows of your data frame. If you are working in a notebook, so your print statement is not that pretty, it's not well formatted. So if you simply do this, if you just simply call this head function from the data frame, it will print nicely formatted, and you can also scroll. So that's why I did not use print statement here. Okay, so now you know how to load CSV file into pandas data frame. How we can do the same for Excel file. Nothing much difference except the function. Read CSV was the function we used for CSV file. Read Excel is the function we are using to read Excel file. Again, this function also contains number of parameters you can provide. One parameter is, you can say if your Excel file contain multiple sheets. That is the case for many Excel files. Probably you will find in your work. In that case, you need to provide what is the Excel file name, right? So sheet name is the parameter. We will explore that in a later time. Here also I'm reading the file using the read Excel function and printing top 5 rows using head function. So nothing surprising or nothing different from what you have seen above with the CSV file. Okay, you see, but how easy now than what you did before with the OpenPyXL. Okay, you don't need to write all this code, but you can do it within 2 lines, or just 1 line to load the file. Sorry, so the Excel file. Okay, so what is actually happening here? So in pandas, they actually using OpenPyXL within the pandas library, that is for sure. we can go to inside the Pandas library code, and these are open source code. You can look at it, and they're using OpenPyXL to do all the processing, all the things we did above for you. You don't need to code everything, but you just need to provide the path name, and everything is taken care by Pandas. Okay, so let's try to move forward to our JSON file loading. This is also the same. Instead of read CSV or read Excel, you say read underscore JSON and provide the path name. So let's see how it reads. This read the same way as before. You read the JSON. So we saw the JSON how it looks like in the text file when we load it, right? We saw how it looks like in the browser when we load into browser JSON viewer from the Firefox browser, and then how we load into Pandas. So it will load the same way as you load any other data file, CSV or Excel, and it will create a data frame out of your JSON, and then you can see first 5 rows of that data frame we created from the JSON file. Okay, so nothing much difference from what you have seen above. All right, I hope this is clear for you. If you are not clear, you can go back to what we covered so far, or go to the documentation from Pandas library and then read more. If you have any question, you can find it on the FAQ section, or you can post a new question if you have a question you never have the answer there. All right, so then let's look at, so now we load the file. Right, so now you know how we can load CSV file, Excel file, and JSON file into Pandas data frame. Right? Like I mentioned, so these variables we created, CSV underscore df, Excel underscore df, they all contain same data, but they are all data frame objects. So we can verify that. So let me verify before we go to the next section. So let me verify what is the type. So you know now what you need to do. You can say type CSV dot underscore df, that is a Pandas data frame. So we made sure they are a data frame object. So you can do anything you can do with data frame, you can do with the CSV underscore df. From here onward, I'm going to use CSV underscore df data frame, which is our loaded data from CSV file. Nothing special there, but I just wanted to choose one out of 3 data frames we created from JSON, CSV, and Excel. So I choose CSV underscore df. The first thing when we load a data frame data set into a file in our data analysis workflow, it could be for creating a dashboard, it could be for to do a data summary, create a data summary, or it could be towards like you are preparing data for a machine learning solution, right? The first thing you should know is you should know what is your data telling about. So you should have a better understanding about the data before you do anything with it. You need to know what are the columns in the data set, how many columns, how many rows exist, what are their data types, whether there are any issues with the data from the first look, right? Whether there are any missing values, etc. So there are a lot of things I'm not going to discuss in this course, because this course is a beginner level course, and we are trying to get you introduced to these libraries and how you work with Pandas, how you work with Python, right? You are learning from the basics. Therefore, I'm not going to go into detail. These things will be covered in another intermediate or advanced course for like Python, how we can use Python for machine learning. But for your introduction, so you have to say you can do call CSV underscore df dot info function to know many things about your data set or data frame you loaded. So info function will return, remember this is a function, you have the parentheses. Without function it will be a different attribute, it will return a different result. Make sure you call it as a function from the data frame object. It will return many useful information. So the first thing you can note here, it will say what is the data type. So we already knew that. And then we know what is the range of index. So we will get to know about what is index if you are not familiar with it. But it will say how many records in your data set or data frame. It tells you we have 100 entries, means we have 100 rows in this data frame. So they are labeled with the index 0 to 99. We know in Python, you should know now, index start from 0, right? And then those rows labeled from 0 to 99. We have 100 entries. And then the next useful information is how many columns. So those are some questions. If you have a data set given by your client or your employer or someone who is working with you, so if you got a data set, you have to have an understanding of the size of the data set, how many rows, how many columns. So that this is one way you can check that using the info function. You know now 20 columns and 100 rows. And also you will get to know immediately what are the column names of those 20 columns and how many values in each column, right? The value counts. If you find any missing values or for any reason there's a none value in any of these columns, he will see a value less than total number of entries, less than 100 here. Okay, and then because it's a 100 not null, you have to have values to say that, right? And also it will say what is the data type of each object. So the here like ID column, we loaded it as an int 64-bit integer, and animal name loaded as an object. So the object stand for strings. So the strings, I cannot say object stand for string, but strings in a data frame load as an object in Python. Okay, there's no explicit string data type used by default in Python in Pandas. The here is another column. Data type is int, and almost all the columns you have here are the rest of the columns you have in the last column are all int columns. Okay, the last column is also a string column. The type name is a string, and the data type is object. So now you have an understanding of how we can get the data types. If you have any floating point columns, you will see the float 64 appear here as the data type. Okay, and also it will give a summary of how many columns from a breakdown of data types. So we have 18 int columns and 2 object columns, which are strings. And it will also give you some information like memory usage. So what is the memory occupancy from this data set? If you are loading like a bigger data set, this will be a useful thing to know how much RAM size is occupied by the data set you loaded. Okay, so in this case, if when you load a file into a data frame, it occupies the memory. Unlike like a file object you create earlier, when you load to a list, it will occupy the memory, but until then it will not occupy the memory. But when you load a data set to from Excel file or CSV file or Json file into Pandas data frame, it will occupy the memory unless you explicitly do something else. Okay, so this is the memory occupancy for this small data set. It's a small data set. That's why you say 15.8 plus kilobytes. Okay, so now let's look at another way you can see what is the row and column number of rows and number of columns. So that is an attribute in the data frame. You can say dot shape for that data frame object. It will return a tuple. The first item in the tuple contain number of rows, second item contain number of columns. So you see 120. The function this is an attribute, not a function. Data frame dot shape. All right. This is like I just wanted to showcase you. I already showed you in this video before how we can see the data frame in Excel. So this data set in Excel, when you load Excel, you already have seen this. So we can if you wanted to get the first 10 rows out of our data frame object, we use this head function earlier without any number. We came to know it will return first 5 rows. But if you wanted to display n number of rows and any rows you want, so in this case if I wanted to display first 10 rows, you have to specify how many rows you want. So here I'm going to say 10 rows explicitly to the head function from the data frame object. It will display you first 10 rows, right? If you wanted to display last n rows, so you can in this case I'm going to demonstrate how we can get last 8 rows from this data frame. You have to say tail. So remember, the head is for first number of n number of rows. If you don't provide any value, it will be 5 rows. If you provide value, it will be number of rows you provide. Tail is stand for the last number n rows, right? So if you provide any number, you will return last n number of rows. If you don't provide any number, same as the head function, it will get like last 5 rows. And let's see how we can get last 8 rows. We get last 8 rows. You see the ID is we have 100 rows and we have last 8 IDs and last 8 index. So the index is 1 less than a number of rows. Is 99 is the last item or last row in this data frame. Okay, so now we know how we can get first in number of rows and last in number of rows. If you wanted to pick a random sample of rows from your data frame, this is also be useful in some data analysis tasks as well as for machine learning related work. If you wanted to pull a random sample out of your data frame, this is how you can do that. The function is csvdf is your data frame object name or variable name, and then you get the function name is .sample. If you call this sample function, let me do this first. Let me call the sample function without a parameter. It will return a single row out of it. When you call it again, it will be a different row because you are randomly pulling a sample, right? So this is a random row. So if you call it again, it will be a different row. If you wanted to specify how many number of rows you need to pull, in this case, I wanted to pull 5 rows. Then I will say, give me random five rows randomly picked from my data frame. This is how we instruct to pandas. .sample, we have to provide n, so 5. So here I should get 5 rows randomly pulled from my data frame. So you see, there's no order of the indexes, right? Indices there's not order. So if you call it again, it will pull another 5 different rows. So if you call it again, it will be a different 5 rows, because every time when you execute this function, it will randomly pull a sample of 5 rows from your dataset. Now you know how we can get head or the first n number of rows, last n number of rows, or n number of random sample rows from your dataset. Okay, so now let's explore how we can see the column names explicitly, or if you wanted to take columns as a list. Previously we looked at how we can use the info function. Info function will print output into a screen, and it will show you like the column names, the data type, and non-null values, etc. But if you wanted to take list of column names programmatically to be used in any of your application, so this is the way you can get it. So your data frame name dot columns. The columns is an attribute, same as the shape we use to get number of rows and columns above. Columns is an attribute. If you execute this, it will return an object name index, but you can convert into a list as well. So this will include a list of column names, right? As it appear on your data frame. If you want to convert into a list explicitly, you can say list. Will create a list of column names. Even if you don't do that, so you can use it as a list without converting it. All right. In the same way, you can get index. Index stand for the index of each row, right? So that index will very similar to what you see in an Excel file. So I first introduced you to Excel file, because most of you are familiar with it. Row number stand for the row number here, start from 1 to n number of rows. So you have the number is rows numbers, and the columns are numbered labeled by the alphabet characters, right? In Python, columns can be labeled by either numbers or by the column name you assigned here. So we have a column name defined. You can call column by column name or the row index. Okay, if you wanted to get the row index, the list of row index, you can get it like that. Here you see you don't get an index as a list explicitly, but you get an object and it will say starting index is 0, stopping index is 100, excluding 100 actually, and the step size is 1. So that's how the pandas data frame describe your index values. If you want to convert into a list explicitly, you can say csv.df.index. I'm going to comment the first line and I'm going to enable the second line, and you can say to list. This will convert your list object into a list, and you can return explicitly a list. So you'll see 100 items, okay, 0 to 99. You can also do the same thing I showed you earlier. You can also enable the third line in your notebook. You can say csv.df.index, the returns an index object. You can explicitly create into a list object using this expression. It will also return the same thing we can execute. Alright, so now you know how we can access column names and list index labels. Alright, so here if you convert your list into index into a list, and then if you wanted to see first 5 index values, so this is how we can use in Python limiters in a collection object. So get me everything from the beginning to the item number 5. So excluding index 5, so item number 5 is included here, right? So this 5 stand for the index. Index is 5 is excluded in the result, so therefore we should get 0, 1, 2, 3, 4 indexes, right? So you should get actually 5 items. You get 0, 1, 2, 3, 4 as we expected. Okay, so this is how you convert your index list index to a list, and then if you're going to get top 5 values here from any list, you can do this. All right, so now we know how we can understand we can get the index and column names. Now I showed you earlier in Excel file, right? So in Excel file we can access any row by the row column by the number and the column name, column letter, and also I can find the address of each cell, right? So this is I7 H7 because H row and 7 column. So H column and 7 row. So we say H7. Same as that we can do in Pandas. So if we load the data frame, so the data frame is now your spreadsheet. If you wanted to get a cell, you can isolate a cell out of your data frame. You can do that. So to address a cell, you have to use another thing called iloc in Pandas, right? So here this is not a function. This is used to extract or like give Pandas data frame instruction to extract me this cell value or set of rows or set of columns or combination of rows or columns to get a region out of your data frame. So here what we are telling is give me row index number 2 and column index number 1. So what is the intersection? We get a cell out of it, right? So before we do anything, I would first print the top 5 rows using our head function to show you like how it actually looks like and what we are actually pulling here, right? So let's see that. So row index 2, this row, okay, column index number 1, so the column index number 0, column index number 1. What you should get, you can think now. If I ask you the question, you should tell me this is bear is going to return. As expected, it returned bear. This is by using iloc, right? Iloc, you need to provide within square brackets your row index and column index separated by comma that will return value for that cell. If you use loc instead of iloc, then in this loc you need to provide the labels of your index and your column. Remember, another thing I wanted to let you know is this index you can label as you want. You can assign another column as index, so you can have alphabet characters in the row index as well. Unlike Excel, you can customize this row index same as your column index, right? Your column names. If you are using labels, so this you can provide. If you are using labels, you can, if you want to use those labels to locate or give address to row and columns, you can use loc. Even if you use labels or use numbers, if you want to use by numeric or the starting from 0 to the n-1 as your numbers, or if you wanted to call your columns by number, you have to use iloc. I is stand for this index, right? If you want to call by name, you have to use loc. Here I'm telling pandas, give me the value in row index number, index label 2. So here in this example, your index label and index value is both are the one, both are the same, but in the column is different. Column we have a label now, so the second column or the second column or the column index number 1 column has a name called animal name, so we have to provide that animal name. So we have what is expected, same thing as above. So we are trying to get the same cell, so which is this cell. So we are getting bear, index number 2, column animal name bear. All right, so now let's see how to extract a value out of it. So extract a column out of your data. So here we are extracting animal name column, the entire animal name column. So how we can do that? You have to say data frame. You have to use double square brackets, because if you want to retain a data frame from what you are calling here, you have to retain a data frame name. Therefore, you have to provide a list of column names. So here I'm providing a list of column names, but that list contain one item. So if you do this, it will return you your column as a data frame containing one column only. If you wanted to do the same thing with iloc, you have to say, so we know the animal name column is our column with index 1. You can say give me all rows, so that stands for this colon empty in both sides. You are telling give me every row and first column as when you are providing list of columns, it will return you a data frame, and give me the first column, index number 1 column. So it will return you the index number 1 column as we expected. And if you wanted to call by the name or label animal name, then you can also provide as a list of columns is one, and then give me all rows. But now you are not calling iloc, you are calling loc, because you are calling by the label of that column, right? All rows, but the column animal name. You get the same as you expect. If you don't want to retain the previous 3 examples, you get a column out, but you get a column out as a data frame, right? If you want to take a column out as a series, so series stand for a column in pandas data frame. Pandas data frame made of a set of series, right? So each column we can take it out from the data frame. Each column will consider as another object named series. Okay, so now you can understand data frame is a compound object made of series, right? So then you can if you want to take a column out, you can take a series out like this. So without putting double square brackets, you are just giving the within a single square bracket, you are giving the column name. So this will return you a column as a series, right? So this is how a series looks like when you are printing in Python in Python notebook, or if you are printing in Python script, you can also get a similar output. When you are printing series, it will say what is the column name, and then how many records are there, and then what is the data type. So that's the typical output you get when you are printing a series. And then if you wanted to get the same thing from the iloc function, remember we are not using square bracket, we are not providing a list of column indexes, therefore it will return a series as well. Same thing applies when you are using a label. We are using the loc. You are providing a label. We are not providing list of columns now. You are providing single column as a string. This will return as a series as well. You are telling give me all rows from this column. Okay, so nothing different from these 3 versions of extracting column as a series. Okay, so you can use either one. Okay, so now let's look at how we can extract row. So we are at the very end of the notebook, so we'll be ending this very soon. Therefore, stay with me for like few more minutes. Extract row as a data frame. So if you wanted to extract a row as a data frame, here is how you can do that. You can provide within square brackets, you can provide from which row index to which row index, same as you do in array or a list. We use this multiple times. You can also do this in a data frame object, right? So to index number 2 to 3. So what you get get from here, 2 is included but 3 is not, right? If you want to get multiple rows, you can also do this. I will have it again, but I will show you. So it's 2 to 5. So what think like now what should be included in the result? You should get row index 2, 3 and 4, not 5. Okay, as expected we get it. All right, so let's go back to this. Since we are now discussing to extract a single row, row number 3, row number 3 and index number 2, right? So this stand for like index, starting index, ending index, return, which will return excluding the ending index. All right, so now let's get the same thing with iloc. So if you wanted to call iloc, you don't need to provide a column specifier here for the iloc, same as you did above. You can simply say index 2 within square bracket. This will return you a data frame, right? So if you are giving list of indexes, it will return your data frame to iloc. If you provide list of indexes by label, list of indexes, that's why I say square bracket within square bracket, a list of indexes, and then it will return a data frame, but just one data frame with one row. Okay, so this, remember, like the important thing to highlight here is double square brackets, use of double square brackets, because you wanted to get a data frame out of the result and as a row. But if you don't want to get a data frame, you can convert this row into a series, right? In a series, we have index and value for each item in the series. So what we can do is, if we consider this as your index of that series, right, a column name, and the value is your value in that row, because we have only single row, so we can easily convert into a series. So let's see, and then I will explain. So what happened here, your columns became index and your values became the values of that series, right? And then the series name, your index value of that row will become the series name. So that's why you see the name is 2, right? So we are just thinking like, think of like a transposing your matrix. You're converting rows into columns, columns into row, but in this single row you're converting into a index value pairs, right? Same as a dictionary, you can think of like this is the key and then this is the value. All right, so we can do the same thing with the loc function by providing the label index without double square brackets. So it will also do the same thing as above we did with the iloc function by providing a label index numbers. Okay, now you know how we can convert, how we can extract a row as a series, as well as row as a data frame containing one row only. Okay, so we are at the end of the notebook, so we will be ending like in a couple of minutes. So now our item here is to extract a cell range. If you're familiar with Excel, if you wanted to extract or if you wanted to call a cell range, you can select, right? So this is your cell range, right? If you wanted to create an equation, we will discuss this in detail when we are discussing about data analysis. So you can say from starting from H7 and ending with K11, right? So that's the row. If you wanted to select a column, you can do that, and you can call like a column D, you can call it in equation, and row 3 A3, or row number 3, you can call all cells in that row in an equation. So let's go back to our notebook. If you wanted to extract a cell range, you have to specify from which row index to which row index you would consider as the range, right? Again, I wanted to print Let me print first 10 rows for you to see it better. So I'm printing first 5 rows. Let me print 10 because I'm calling from row number 4 to 8. Okay. So I'm telling Python, give me rows starting from 4 till 8, excluding 8, right? So what you should expect, row index 4, 4, 5, 6, and 7, not 8. And then give me columns. I remember I'm using iloc. Columns index number 1 to index 6. So index 1 is this. Animal name is your index 1. Index 0 is ID, right? 0, 1, 2, it will go like that. 2, 3, 4, 5, 6 up until this, right? 6 is the airborne. But in Python indexing, so in this range, will I get this airborne? No, because the 6 is should be excluded. I will get until index number 5. So I should get, I cannot select a region here, but I can get animal name column until milk column, and rows from row number 4 through row number 7. So let's see whether we get the same thing as we expected. So let's explore that with the output above. Okay, row number 4 to 7, that is correct as we assumed. Columns animal name to milk, that is also correct. So that's what we get from selecting a cell range from your data frame object. You see like how easy, it's the same as you do in Excel. What you need to know is we need to understand this syntax and how you can call it, and you have to understand the ranges, how you define in Python the ranges. So if you know that, you can easily do data manipulation in Pandas, same way you do in Excel. Probably you will find Pandas is much easier after you learn it. After you complete this course, after you learn it, you will find Pandas is much easier, and you will be more convenient using Pandas than Excel. All right. So if you wanted to get the range using the lock instead of iloc, if you wanted to explicitly say labels, right? So again, like your index rows are still a numeric index, so therefore I can say 4 to 8. If not, you can also say labels. If you wanted to give a list of column names, you can do that. So same thing, I'm giving explicitly, I'm giving names, animal name, and then other columns I want to extract, so we get same output. Okay, that is using lock with the labeled column index, column names, instead of using the index values, range of index values. Okay, so now you use row range and selected columns. So now so here, like I selected a range of columns, right? So these columns should be consecutive, so it should be right adjacent to each other. If you're selecting a range, you can also you can pick columns like, you know, skipping some columns, right? So if you wanted to pick say like animal name and not any of them, and you can pick airborne, and then you can pick predator, you can pick fins, you can pick lens, and you can pick the skipping all others, you can pick the last column, right? You can provide a list of columns skipping items, and same as the iloc, to the iloc function also you can provide list of column IDs or column indexes, right? By skipping some, right? So you can say give me all rows, so give me rows in this range, but only these columns, right? Some columns are skipped in between, and then it will print it for you. And same thing you can do with the iloc, right? You can also give like a row index as also a list, so you can say 4, 6, 7, I don't get me 5, and then 1, 4, 5. So you are skipping rows and columns, you are just providing list of rows, row indexes, and list of column indexes. It will give you a selected cells for you, same as we did to select one row. You can also provide list of so let's then explore one more thing before we close. So let me, so do they need to be in order? Probably you will have this question now. So let me say, okay, 8, 2, and 7. I would say 4, 1, and 5. So let me do that. 5. Okay, so what we expect is should be in the order you specify, right? 8, 2 and 7, column number 4, 1. So 1 is the animal name, we remember that, so that appear in middle because that is how we order it in this iLoc. Yeah, therefore you can provide your column name, column labels, or column index, or row names, or row index names, or row index numbers by any order you want. Whatever the order you provide to loc or iLoc, it will print it for you in the same order. All right, so now in this notebook you now know how you can deal with Pandas data frame, how you can load a data file, either CSV or JSON or Excel file into Pandas data frame, and then how we can navigate through the data frame, and how we can go to cells, I can extract cells, or how we can get a value of a cell, right? Or how we can extract a column, or how we can extract a row. Some basic operations you would like to do in Excel, you now know how to do in Python with Pandas, right? So in the next lesson we will explore how we can do some data analysis work, and how we can visualize this data using matplotlib and other plotting library we are going to explore. All right, so I hope you enjoyed the lesson, and get ready for the next lesson. It will be very exciting. This could be like little boring because we just work with the data file and we try to execute some commands and explore the output. But in the next lesson we will be a lot of data analysis work, and you need some thinking, and when you are doing a data plotting, it will be a good exercise you can do. You can think of like some plotting ideas, what is the best type of plot for this data set, and you can change colors, you can add some creativity and some thinking to analyze data, because that's the most interesting part. We are going towards end of this course. When you are getting to the end few lessons, so you will find more interesting thing, and you can get some hands-on with some application related work. All right, so we will see you in the next lesson.